In today's math lesson, we're going to write compound inequalities from graphs. Quick review. If you have a graph that is shaded in the middle, then you are working with an AND situation. And it is usually written as a number less than X, which is less than another number. This can also be written with two separate inequalities and the word AND between them. If, however, you have a graph where things are shaded on the far left and the far right sides, that means that you have now got an OR situation where things are written as X is less than a number or X is greater than another number. So that'll be a quick statement just to help you remember very quickly what it is we're looking for. Example number 1. What compound inequality describes this graph? We quickly see that this graph is shaded on the opposite sides, which means that we must be using an OR statement. OR tells us that we're going to be shading on opposite sides. And we saw in the introduction, the quick review of a previous lesson, that OR statements are always X less than a number or X greater than another number. All 4 of our answer options are OR statements. Great. So we are in agreement there. Okay. So this tells us that we have to look at what's happening at our 2 points instead of just the OR. So our 2 points, let's look at them. The 3 has an open dot. And the 8 also has an open dot. So we know that our inequalities have to be a less than and then a greater than. So I have less thans and greater thans correctly given. But since they are both open dots, that means that we will not have any bars. We're not equal to anything. Therefore, both of my 3's and 8's, my 3 and 8, that's a lot of words, cannot have a bar underneath their inequality statement. And there you go. Example 2. What compound inequality describes this graph? We reviewed in the introduction that if you have a shaded section here in the middle, then you have an AND situation. So the word AND could be used in your inequality statements, or it could be written in a different way. So AND statements have the shading in the center between your 2 points of interest. And it could be written out as an inequality with the word AND in the center, as these do not show us. Or it could be written as one inequality statement with a number less than X less than a second number. And that is what we have going on here. So I already know that these 2 answer options on the left cannot work for us because they have the word OR. These 2 answer options on the right are in the correct arrangement. Let's go look at what's happening with the points of interest. -1 is an open dot. And +4 is also an open dot. That tells us that both of our less than symbols cannot have a bar underneath of them as they are open points. So -1 is less than X, which is less than 4. And there you go. Example 3. What compound inequality describes this graph? We quickly see from the graph that we have shading in the middle. And we stated in the introduction that that means that this is an and situation. Okay, so that tells us all right now that both of these two answer options cannot be it, as they both have an or and not an and. While my other two options don't say the word and, they are in the correct arrangement where we saw in the introduction that our inequality could be set up as a number less than x, which is less than another number. Okay, that being stated, let's go look at our points. 2 has an open dot, but 7 has a closed dot. This means that these 2 points do not have the same symbol with them. The closed dot has a bar underneath the less than symbol. It is less than or equal to 7, which means this must be our correct answer. And there you go. Example 4. What compound inequality describes this graph? Well, we immediately see that the opposite sides of this graph have been shaded. It's shaded in opposite directions. That means that this must be an OR graph. Okay, that tells us from our 4 answer options that the 2 answer options here on the right cannot be it, as they do not have the words OR in them. Okay, it's time to go look at our points of interest. -8 has a closed dot. And -5 also has a closed dot, which means both the less than and the greater than of our inequality must have equal to's on them. And here it is. And there you go. In our 5th and final example, we have to determine what the compound inequality is that describes this graph. Well, we are not given any answer options to choose from, so we have to figure it out ourselves. Okay, so let's look at our graph, and we see immediately that it is shaded in opposite directions, left and right. And whenever you are shaded in opposite directions, that means that you are working with OR. Okay, so now that I know which one of my 2 setups, my 2 arrangements I'm going to use, I have to use this OR arrangement. That means we can just go ahead and figure out what we're going to be using. We know that we've got x and a 2, or x and a 6. Let's talk about our symbols between them. Okay, so this 2 is a closed solid dot. And our first piece of the inequality always uses a less than to go with it. So this is going to be a less than or equal to, because it is a closed solid dot. And over at our 6, this is an open dot. So with our second inequality piece, it's always a greater than, and due to this being an open dot, we are not going to put a bar underneath of it. It is purely a greater than. So we were able to deduce because of the shading that this is an OR statement. We were given a hint as to how to set up an OR statement. And then we needed to place in our own numbers that were appropriate to our graph, and then use our symbols based on whether or not we had a closed dot or an open dot. Thus, x is less than or equal to 2, or x is greater than 6. And there you go.